Communication on networks is done through data transfer or a transmission, a digital transmission, okay? And basically what's happening, it's a physical transfer of data. You know, it could be digitized analog signal, which we'll talk about a little bit, or it could be into a digital stream. It goes over from one point to another, just like that picture, basically. The little lines are going from one device to another. You know, it can be point to point, or it could be multiple points. A computer network is a group of computers basically connected together, and they're linked, so they have communications channels where they can actually facilitate the network and facilitate the communication, the resource sharing on a much bigger perspective. You know, we get rid of the fact of having to save things to USBs and transport them. We have wires, and they're basically broken down. All these wires and how they are set up in patterns are broken down into characteristics, which we're going to learn later on as we go. But computer networks help us by connecting these wires or wireless. We're connecting and facilitating the email system, the video sharing, you know, the conferencing, the email, enabled sharing hardware with others like a printer or a scanner, file sharing across the network, able to print from your desktop to the main printer in the main office because it has color, whatever you want to do. Remote access from home. These are all things that networks allow us to do that previously we didn't have access to. Networks are typically broken down into 4 areas. 3 are the most commonly used: the local area network, the personal area network, and the wide area network. As you get into bigger businesses and bigger corporations, you'll hear it, metropolitan area network. It's similar to a local area network. We'll start at the bottom, work up. On a LAN, but it spans an entire city or campus. So it's on a large scale. Usually, until you get into a big company or a government agency, you're not going to hear that talked. A wide area network basically is not limited geographically, okay? So what it basically does is it's a WAN connects different smaller networks together like a LAN or a MAN, and a LAN's at the top. So the local area is limited geographically. So it's within a building, it's in a laboratory, it's an office. So let's say all the computer labs are connected together. Internally, each computer lab has their own LAN, but once we get going from one building to the other computer lab building, you're going to notice that that's going to have to go out on a WAN. So WAN is a big connective. It connects bigger and smaller LANs, even personal area networks, such as a computer network used just to do basic stuff at home or in a small office. So if you look at it, we have these personal networks. Okay, and in some cases we do have a MAN, okay, and then they're going to be connected. So if you're in one building, you want to communicate with somebody else, you're going to go through your LAN onto the WAN and into another LAN. So the big key here is LANs are limited. Personal area networks are limited basically too, but the WAN is going to connect everybody together. Okay, even the bigger MAN connectivity. So this is kind of the structure. We'll get into topologies in just a little bit of how you lay it down and what type of network characteristics it has. But no matter what it looks like on your internal network, if it's a peer-to-peer or if it's a client server, or even if you have it set up in Star Token Ring, it's going to be some type of broken down into a LAN because it's limited geographically, or a WAN. And that's basically the only time you'll have a WAN is when it's connecting 2 smaller networks together to make a bigger structure, kind of like what we've done with the internet. It webs things together. All right, now we're starting to get into the architecture. We talked about the LAN, the WAN. Now we're going to dive into a LAN area, okay? So we're in a LAN looking at how it's kind of structured, the architecture. And usually it's broken down into 2. You've got a client-server network. It's where one server or one computer is centralized and everybody else revolves around it, kind of like a hub system. It's the base, it's the mothership. Everybody goes through it. Then there's the peer-to-peer where everybody has control. So you don't have a server, you don't have a main connect area. You might have 5 computers in there and they're all the same. So that's kind of a peer-to-peer, and they go from one computer to the other and kind of daisy-chained together. Most small offices are probably set up like this, but it's very easy to set up in a client-server network, because client-server network gives you, one of the big deal is, it gives you some security and some logon rights so that not everybody is utilizing or able to utilize that you don't want your resources. So the network architecture, once you get into LAN, can kind of be broken down into, does it have a server or it doesn't? If it doesn't have a main server, meaning the big mothership, somebody that kind of sets the rules like a principal of an elementary school, it's probably a peer-to-peer network. All right, it's very important that you watch the previous video because it really laid down the foundations, and I'm not going to overkill this thing. But network topologies, remember we talked about the LAN, then we talked about it as a client-server network. Now we have to figure out how is it physically laid out. Okay, there's the star network, which they kind of talked about, where there's a center and everything radiates out. Okay, it is the most popular one out there, so you really need to be aware of that. The ring topology, the video goes in and kind of says they don't see too many of them. I know Fresno State still has it on the outside, so they have some star topology built in inside in all the little buildings, and if you have to circulate the campus quickly, they will do it on a ring topology. Then there's the bus system. It's kind of very linear. I always like to look at the bus system as like your sprinkler system. Okay, here's the only problem with the bus system. If you were on a bus, what happens if you break a sprinkler? All the water squirts out there. Okay, and then as you go down the line, there's no pressure. So that's the problem with a bus network. If one person at the beginning is sucking all of the bandwidth, let's say, Comcast is kind of set up in a bus topology at the home level, not at the business level, but the home level. So if you live on a street and there's somebody sucking the bandwidth, now they have ways to keep this from happening, but let's say they're watching videos and there's 20 computers in there and they're all watching videos, and you're at the very end of the line of the bus, your bandwidth is going to be slow. The latency is going to be bad, meaning it's going to slow down and you're going to have problems connecting. Okay, so it's very important that you watch that video, that you understand the topologies, how they physically are laid out on the cabling and the wiring, and how it structurally works. Okay, now we're going to look at some standards. We look at the layout and we talked about token ring, okay, or the token structure or the ring structure. Now we're going to talk about the internal, okay, lay the line down in the line, what type of communication, the protocol, the rules of the road, including the guides, the regulations, the characteristics. These are all in the network protocol. How fast, the data transfer, are there collisions, all this stuff. And some of the big things we're going to talk about are Ethernet and token ring, okay, and then there's the TCP/IP that we talked a lot about in networking. I'm not sorry, in not the networking, but in the internet chapter. But Ethernet is very popular. But the problem what's going to happen is it's usually set up on twisted pair, and and they work together, but there's collisions on the line. You're going to see some videos talking about it here. And it's kind of like a chaos system. They send information out and they wait to see, did you get it? Okay, but you got to understand that when we send information out, we don't send it like a Word doc. It takes the Word doc and divides it up into packets, very small little packets, 3, 4, 5, and it ties your IP address, which we talked about in the network, and your physical NIC card, which we're getting ready to talk about, and it puts it on each one of these packets and it sends it out. And if it doesn't get an acknowledgement saying it received the packet from the desk where it's going, it just sends it again, because what happens, it's so chaotic and there's collisions all over the place. In this lecture, at the very last video, it's kind of a comical video, but it does a good job of describing the whole entire network and traveling on data throughout the internet. Okay, token ring is what goes on a ring topology, and basically it's like a little token that spins around and it goes from one machine to the other, and when the machine wants it, it says, hey, hold on, stop right there, I want to put a token on there. Okay, there's a video coming up, or you maybe already seen it, that talks about the insides of the token ring and how it's passed. And there's not a lot of collisions, but it can be slower because it's not chaotic. Okay, it's one at a time. Move to the left. Let's go. Okay, and the TCP/IP, again, it's like your address. Okay, it attaches everything at home. If you send a letter to somebody, that's how it gets there. TCP/IP is the rules of the road for the internet. It takes your IP address, puts it in there, packages it up. Make sure you know what an IP address is and how it's divided up. You should know it after the network or after the internet chapter, and we go from there. More networking protocol here. You have Bluetooth, you have Wi-Fi, and IRDA. Now, Bluetooth was originally coming from the European side, and you know what? They started to put it into personal computers, and the PDFs and all this other stuff. But what it's really landing on, it's a wireless signal. Okay, it's a short distance. Okay, about 30 feet is the distance. So Wi-Fi can go a lot farther, but you're seeing it landing in the car industry. So a lot of your cars are setting your smartphones to the Bluetooth, your headphone systems. You're even having it now Bluetooth infiltrate your entertainment center. So, but these are protocols. They're rules. Bluetooth has certain rules. Okay, and that's what we're trying to get at with what's going on with the Ethernet and all this stuff. So they're still kind of grouped together, but these are more your wireless protocols here. You have your Wi-Fi. It still basically facilitates, with your smartphone and your networking devices and your hubs and your switch. So those are kind of two standards. But if you're going for the distance, you're going to do Wi-Fi. If it's a short distance, headphone distance, smartphone distance to the car, you're going to do Bluetooth. Okay. IRDA, basically that's the one. It's the basically point and shoot principle. Most remote controls, they still have it around in that. It's the deal. When I was young, if my sisters would have the remote control and I couldn't get a hold of it because they were all bigger than me, I would take my hand and cover the front of the TV where the little window, red little window was, and the remote control wouldn't work because it was a line of sight. Okay, so devices such as that. In my traditional classroom, I have a clicker that advances my slides, my PowerPoint slide, and it uses an IRDA. It's a line, it's a point and shoot. It has to see a window, and it is for short distance as well. All right, the last standard we're going to talk about is RFID, which is a wireless frequency. Okay, they use it wirelessly to go to some type of a barcode system. Electromagnetic field. It transfers data, and it's a small amount of data, and it has to be within 20 feet. If you look at the diagram there to the left, you'll see what happens. Trucks come in, it goes through a scanner, it automatically picks it up, it puts it on the wall. It's a processor. It cuts down on manpower. Okay, Walmart is already using it. UPS always using it. I always like to see, if you look at the Minority Report, where he walks in and is able to identify who that person was in the movie Minority Report. It's all done by wireless. Okay, you'll have a barcode. Pretty soon they'll get rid of checkout counters because they realize that if you wait in line long enough, buyer's remorse is great, and you might return it. Especially, sorry to pick on you women, in women's clothing area. If you're waiting in line, you can talk yourself out. So like you go to the Mac or the Apple store, they'll say, here, check you out right there. All are going to be done RFID. If you're ever sitting home or you want to Google a good show, I recommend that you watch the Walmart story. Believe what you want, and I am not doing a political thing, but from an IS standpoint, what they're doing with tracking and delivery, they're even looking at weather patterns in certain areas. They're saying if this basically region has the same weather pattern as this region, and this product is selling well, let's move the same product into this area, because they have the same climates. Or, they look at these weather, if a tropical storm's coming in or a hurricane, they know what sells the most during hurricane, and they start moving the product. Hot dogs and plywood, it's going to those Walmarts. Okay, so they do a really good job of using data, RFID, to check what's happening. The only downside about RFID, it really does cut down on manpower. So As we get these into the hospital systems and everything else, we're going to need less data entry people because it's going to be done already. We're going to know when you check out things, and we might not even need a clerk there to respond to it, because as you walk in, it's going to say, oh, Mr. Neighbors puts XYZ into his shopping cart, and as he walks out, it says, thank you. It's already billed his credit card. You walk through these little sensor things, and it's done. But at the same time, they can say, hey, Mr. Neighbors is probably 30 years old, which I'm not, but that's great if you think that. He buys this products. Well, okay, 30-year-olds buy these products. Let's make an aisle. Every time somebody buys Pampers, they buy this. So why not put them together? And in one of my weird brain ideas, at some point, you might turn down an aisle and they're able to make the products that you want right on that aisle. You know, all of a sudden you're like, wow. It's like Amazon. If you've ever been shopping on Amazon, and on the right-hand side, all the products that you've been looking at, you're like, wow, how'd they know that I wanted a Traeger barbecue? It's right there. Okay, they're identifying this all through radio frequencies and data. As you look here, there's a chart that shows the different speeds, okay, of the bandwidth and different types of tunnels, would you say. It's much like roads, highways, and freeways. You know, you have cabling, DSL, ISDN, and it goes all the way down. And I don't have the price of each because it changed so much, but those are the speeds. So if you have, I live way out in the country, and there's 5 people that live by me. We have a very tiny road. Okay, I can lay across it and reach both sides. However, if you're by Fresno State or you're on Herndon and Willow, that needs a huge road. So as a business person or an IS person, or maybe managing a business, you're going to have to decide, okay, what type of size of a line do we need for my business? We don't want to overkill it. You know, we live out in the middle of the country, and you don't need 6 lanes out to there. However, you don't want to undercut it. So these are all decisions you have to make because they all have various digital speeds, okay? So take this into consideration, find out how much traffic you're going to have, and you might be the one in charge of this in your business, okay? If you're not, you need to, and I should say this a lot in my videos, you need to understand it because you're going to have somebody underneath you that's going to make some decisions. And if they don't think you know what you're doing, you're going to end up with a really fast network for 5 people, and you're going to be spending a lot of money, and somebody's going to turn to you and say, how come we're not profiting? Well, could be that you're overkilling in the area of IT. Now we're going to start looking at the hardware, what it takes to really, once you get the topology laid out and you got your computer, you know that you're on a star network running Ethernet with TCP/IP. Well, first off, in your computer, you need a NIC card, okay? And you see in the image right there, it basically enables you to start sending information. Your IP address is inside your computer, but there's a physical address that are on each NIC card. And when you send information out from this NIC card, your physical address and your IP are put on each packet. So that's basically how you can identify you. So like I always say in my live classes, and I'll say again now, you're not invisible on the internet. These devices all map everything. They know where you are, what time it's sent. Even if you delete it on your computer, it can be tracked back to you. In there, okay, once you get these little Ethernet cables, twisted pair, going down into your star network, they usually go into a hub and a switch or router. Let's talk a little bit about hub and a switch. Basically, it's a device where all your computers can plug into. It's a central point, okay? It's kind of like the middle of the network. But the hub and switch are basically they're dumb. All they do is plug in and they just say, pass on. There you go. Everybody can see both sides. They can flow from one side to the other, and you get to see what's in there. From a network standpoint, the security issue could be a little bad. Okay, what I always like to do is do routers because routers are more intelligent, and we're going to talk about that in a couple slides here, what a router is. A router will not let people see on one side the other side. Okay, it's kind of like a cloud, but not a cloud. It's just, there's something over there, and I know it is if you're like trying to hack it, but I can't see it. With a switch and a hub, they say, come right through. Some other devices that are out there, again, I mentioned the last thing, a router. You know, it connects multiple devices, much like a switch or a hub, okay, but there is some control on If you look at it, there's the in and the out. It kind of does like a firewall system. Most of them have them built in. It doesn't allow people to see past them like the hub and the switch does. Now, a wireless access point, basically it controls and allows you to disperse your wireless signal, okay, or your data among other wireless devices. Now, if we look at those physical wires that are laid out over the LAN in a star network using TCP/IP, Ethernet. Now the physical look, there's the cable or the coaxial cable. And if you look there, there's some good examples, like your internet's probably coming in if you have Comcast this way. They have a copper wire in the middle, then it's wrapped and insulated, and they put the copper mesh on the outside, and then they put another insulator. The copper mesh is there, the woven braided metal is there so that you don't get electrical interference. So it disturbs the signal as it goes down. It's a very quick and easy way to distribute information and data across the network. Ethernet usually uses twisted pair. If you look down there at some of the examples, there's actually 8 wires that are braided together to make 4. Right here in this diagram we have green, green, white, brown, brown, white, orange, orange, white, and blue, blue, white. Meaning the blue white means the white has some blue on it, and you braid them, and all the way down the line it's braided, and then those are braided. So what happens is they're all afraid. Networking structures or twisted pair does not want data to be compromised. So if they lay next to each other all the way down, data could get confused because it's always running next to that same wire. By twisting it, it keeps it so it's not laying next to the same wire the whole time. You'll also see they're shielded and unshielded. The shielded then wraps around outside of the braided information, and it keeps the electricity from messing up or any other signal that can cause interference within these lines. So hence the word twisted pair. The last type of physical wiring or types of structures is the optical fiber cable or fiber optics that we sometimes refer to it. It's basically fine glass, really thin spun glass. They're down there shielded, okay, and you see there's a glass on the outside, and then these are all put together in wires and stretched, and it causes it creates a very fast, okay, it's very fast. It's faster than the copper connectivity. Only problem is you don't want to bend it real sharply. Okay, you don't usually in the old days when it took a curve, it had to take a big curve because you couldn't break the glass. If you break the twisted glass, your network goes down. Okay, but it's an extremely high and fast rate of delivery. Another type, and this tends to be wireless, is your microwave signals, okay? Electromagnetic spectrums that are sent across. Similar but different spectrums from your microwave. And you'll see later, there's some other technologies. The next slide, you're going to see a video on the Loon project from Google. Very, very interesting in where we're going in space with our connectivity to networking. Please go ahead and watch the 2 videos that talk about the Google cloud structure and their data centers. All right, transmission media basically carries one or more communication signals. Okay, the broadband is basically the media transmits multiple signals simultaneously. Okay, the bandwidth is how big the size is. We talked earlier about the road. How much information can travel over that transmission medium, and latency deals with is it the slowdown of a network. So if you've got a lot of stuff going on, if you're driving in traffic in LA, there's a lot of latency, okay, on that network of cars. That's what we're referring to here.